So anytime we try to represent something that's three-dimensional, like Earth, which is a sphere, and we try to represent that on something that's two-dimensional, like a map that's flat, we always have a hard time. Something gets compromised. Either distances or directions or areas or shapes get distorted. You can see that here with the figure 1.11, the Robinson projection, and figure 1.12, the Peters projection. So what map makers try to do is enact some sort of compromise with that, and then also use different maps for different things. So in this image that you're looking at right now, the upper left is the Mercator projection, which shows Antarctica as being much larger than what we're used to seeing. In the upper right is the mall-wide projection. That's a pretty common one that we're used to seeing, especially in school books. And then the polyconic projection on the lower left, and the azimuthal equidistant projection on the lower right. So your book actually has quite a few pages that pertain to map projections and which projection is best for or most appropriate for different scenarios. And to be honest, we could teach a whole class in mapping and map projections. So I just want you guys to be aware of the fact that there are different projections out there and that they distort those four different things. One of the neatest areas of geography right now is it's sort of the home, if you will, of GIS, or Geographic Information Systems. And it's a really exciting field, that and remote sensing and aerial photogrammetry. What's neat about it is that we can make maps now using remotely sensed data to show lots of different things. So figure 1.13 is a cartogram that demonstrates the spatial inequality of all the people living on $10 or less a day. So if you take a look at that map, what's really interesting is that North America and Europe are in blue, okay, which means that really people there are fairly economically well off. And then if you look at the southern and mid-eastern sections of Africa, those people are densely populated, or not densely populated, but densely distributed in terms of the number of people living on $10 or less a day. And then figure 1.14 shows us how technology can be used to map land cover, and we're looking at the southern part of California and Nevada, and if you know about this area right here is all desert. So land cover there, the desert is being represented by this dark gray color, and then we have the mountainous Sierras through here and more coastal areas. I would challenge you guys to think about what some of the red might be. Now, some of the applications of GIS have really exploded. We can use census data combined with commercial data to do market research about things. What's neat about this is that when we start to map where people live and their demographics and census data that talks about age and education and income level, it really becomes some powerful information that a lot of big corporations and companies use to analyze and decide where they're going to locate. So a couple of really good examples are FedEx and UPS. So they'll actually map out ahead of time what their route is going to be for delivery, and they can do that using GIS and maps and figure out what's going to be the most efficient route for the driver to follow. Another really good example is how a store decides to locate in a particular place. So for example, Cabela's and McDonald's and other types of businesses don't just arbitrarily decide to plop down a store. They do a lot of geographic information analysis and figuring out where the best place to put a franchise is. And I apologize for you guys who are not in Kalispell, but Kalispell has 3 McDonald's, and then Whitefish has 1. And if you can mentally think about where those McDonald's are located, you'll see that they are spread out from each other, and they're also on major routes of travel. If you think about any other cities that you've been to and where the McDonald's are located, and I'm not trying to pick on McDonald's, it's just an example, but if you think about where they're located and how they're spread out from each other, it's all done with a careful formula to figure out, can that place support this business? And as Kalispell grows, we've gotten a new Cabela's, we've gotten a new makeup store, we've gotten new pet store, Boot Barn, all of these things. Those companies wouldn't come here unless they thought that it was worth the risk given our demographics and our economics and the amount of people who travel through here. So for spatial analysis, we are looking at those coordinates of latitude and longitude where they intersect, and we use global positioning satellites to help us figure that out. And when we start looking at the analysis of a place, we're interested in its site and its situation. So its site refers to its physical attributes. So that would be things like, what's the soil like? What's the vegetation like? What's the water like? What's the terrain like? How much sun does it get? And then situation refers to its relative location. So what's the location relative to other places and other human activities? And your book gives an excellent example. So Denver, Colorado is a major center for cable TV because of both site and situation. So the site is good for cable TV because it's at a higher elevation. The location is good in terms of situation as well because it's more towards the middle of the United States. Okay, so I encourage you to be able to think of an example of a certain place, be able to say what its site is and what its situation is. We make mental maps all the time, and I used to do this in my face-to-face version of geography, where everybody would have to make a mental map of how to get from one place to the other. We would pick the starting place and pick the finish place, and then we would exchange those maps. And it was really interesting and really funny sometimes to see how people drew those maps in their mind and then translated those to paper. So for instance, I know how to get to work every morning, but I don't always know exactly the name of the street that I've traveled or how many exact stop signs or stoplights there are, but I could give you lots of reference points on the way. So the mental maps we make are usually very subjective. They're based on our own perceptions and our own experiences. When we talk about distance, we have to talk about absolute or relative distance. So absolute would be like saying the store is 1 mile from my house, or it's 1.5 miles to the next town, something like that. Relative is when we're talking about, oh, such a place is north of this place in relationship to each other. Cognitive distance, on the other hand, is what we perceive in our minds to be the distance. So for example, you may know that it's a fact that one place is only 10 miles away from another place, but in your mind, sometimes that seems like an awful long distance. Okay, so what are the challenges that you have to overcome to get there? It's important to remember that everything is related to everything else. So there's this idea of a friction of distance, which just means what's the time and the cost of overcoming that distance? So you may sometimes think to yourself, is it worth it to make another trip to this place? Okay? And when I say worth it, I mean, seriously, is the cost of driving there and your time worth going that far? And then distance decay function just refers to the rate at which something such as an activity or a phenomenon diminishes with distance. And a really good example is that when you think about where shops and businesses are located, they really tend to cluster together. And then that phenomenon of that shopping complex diminishes the further away you get from it. And then in terms of space, we can also have absolute or relative space. We can have cognitive or mental space. And then we can think about space in terms of topology. So just meaning, what does that look like from a connectivity point of view? For instance, what are the bus lines between one place and another? How do the train lines go? What do the roads in between one place or another look like? So spatial analysis, we're also interested in accessibility. So for instance, how do you get from one place to another? Is there an opportunity for that type of interaction? What's the proximity? So how close are things to one another and why? And then distance and connectivity. So how connected are they if they're distant from each other? As well as the fact that airline hub cities, as an example, are more accessible than other cities. So that accessibility is, what's its ease of getting to? What's the easiest place you can go? And I'll unfortunately give just another Kalispell example. If you want to fly to most parts of the United States from Kalispell, you have to travel through a hub city first. So Minneapolis, Seattle, Salt Lake City, or Denver. Usually you're looking at having to have some sort of connection to get there. So spatial analysis, we also are talking about spatial interaction. So the movement and flows of human activity, how places can complement each other. So complementary places means we're talking about a variation in physical environments and resources, as well as variations in world economies. So as an example, Kalispell or any northern town is not going to be able to grow nice produce outside in the winter. Whereas the southern part of the United States can do that. We, however, have access to lumber and timber that other places don't. So that would be a complementary relationship. Transferability just refers then to the cost of moving that item from one place to another and its ability of the item to bear those costs. So for example, if we wanted oranges from Florida or Southern California and each orange was going to end up costing us $10 a piece, then there wouldn't be very much transferability. Another good example is in Kalispell, one of the only places that we can recycle glass is at Target. And the reason for that is that the market outside of Kalispell for recycled glass doesn't support what it costs to actually get the glass to a place that could recycle it, because glass is heavy and it's bulky and it breaks. Okay, so there's some transportation issues there. So the only reason that Target actually can do that is because they're coming to Kalispell with a full truck of goods and they don't want to return empty, so they'll put that glass on the truck and take it to a place that can do that. There are intervening opportunities. with spatial interaction, which determines the volume and the pattern of movement and flows. So when you think about something that intervenes, we're talking about something that interrupts in between the origin and the destination. Spatial diffusion is the way things spread through space and over time. And there's actually two types of spatial diffusion. One is called expansion diffusion, the other is hierarchical diffusion. Expansion diffusion is the diffusion of an idea or a concept or a good or service that's due to the proximity of the carriers or the agents in change who are in a fixed location. So for example, you may have people on one farm who come up with a unique new idea of how to do things, and then the next farm over adopts the same approach, and then the next farm over adopts the same approach. That would be expansion diffusion. The flip side of that is hierarchical diffusion, where the phenomenon gets spread from one place to another without spreading to the people in between. So for example, if people who live in a city such as New York adopt a fashion trend and it gets sort of taken up and absorbed by people in Los Angeles, that would be an example of hierarchical diffusion. Oftentimes people will ask, how do things like diseases play a role in that? So a really good example is hierarchical diffusion. If you travel to a country and you pick up a virus and you get on the plane and you fly home and somebody else gets infected, that would be a hierarchical diffusion. But if you're on the airplane with someone and the person next to you gets the same virus and the person next to them gets the same virus and so on, then that would be expansion diffusion. Regionalism just talks about how we can really look at different places and what they're like in terms of a region. So functional regions share an overall coherence in their social and economic politics. Regionalism itself refers to different religions or ethnic groups within the same state boundary. Sectionalism infers some extreme devotion, and then irredentism is an assertion by a government that a minority living outside those borders belongs to it historically and culturally. In terms of regional analysis, we're looking at what landscapes look like sometimes. They can be ordinary and symbolic. They can have lots of different layers of meaning. So for example, we talk sometimes about what makes a place unique. And it can be the ordinary things about it, so the mountains or the fields, and it could be symbolic. Okay, so for example, the statue of Jesus at the top of Big Mountain or Whitefish Mountain. We'll talk more as we move towards your midterm project about a sense of place. And even though sometimes you don't think about it, a place has definite characteristics that make you realize that you're there. And we have people who live in places who are insiders. They share codes of dress or speech or custom or habit, and that can be subjective. And then we also have what we refer to as a person's life world, which is just the taken for granted context of everyday life that you gain through shared experiences. And a sense of place can be conveyed in a lot of different ways. So for example, in a book, it can be conveyed through the description about where that's happening. In a movie, it can be conveyed with sort of small shots of different landscapes, for instance. Your geographical imagination allows you to understand geographic change, and then places and regions represent that cumulative legacy of successive periods of change. Your book actually gives this example of South Beach, Miami, and how it's changed over the years in terms of its entire culture and landscape. And then future geographies, we kind of wonder what will happen in the future, especially as wealth and economic power that's traditionally been dominated by Western countries, so Europe and the United States, how that's going to shift as more wealth and more economic power actually is being taken over to a certain degree by countries in the East. And then just want to point out one last thing. These little things, applying your knowledge within the PowerPoint, are always good to be able to answer. Okay, so what are the likely future changes to the geography of your region? And I realize we're all in different regions, so just think about how that applies to you.